Good afternoon and welcome to Rail offices in Riga. And welcome to our final session of Rail Baltica Academy. My name is Raitis Bušmanis and I will be moderating today's event. Before we start, I would like to say a few words about this Rail Baltica Academy and also provide some technical guidance on how to ask questions during this lecture. We see from the list of participants that many of you have joined this Rail Baltica Academy session for the first time. Therefore, I would like to say a few words why we are doing this project. And with this academy, we want to encourage students to choose a career in railway. And we are offering an informal learning opportunity from our senior experts and staff on how to plan, design, and operate a high-speed European gauge and cross-border railway. In this fall-winter semester, we have had 4 sessions with our senior experts, and we talked about a number of subjects, starting from planning of the project to control and command systems and electrification, and today about building information management. Next year, our academy will resume in March, and we will offer 4 new topics. Which those topics will be, we can't tell yet. We will be consulting with you on what subjects to choose for the spring. For those of you students who are interested in internships with the joint venture of Rail Baltica, please follow the chat. We will be posting a form where you can sign up and indicate your fields of interest and availability for the internship. And now, so let's go ahead with this session. We have planned about an hour and a half for the presentation. We encourage you to ask questions during the presentation. Please type your questions in the chat section. We will stop during the presentation at least 3 times and answer your questions on the go. So please write the questions in the chat section. And from here, I hand over to Raitis.
Yeah, thank you, Liva. Thank you very much. So as the introduction was given by Liva, so I'm Raitis Bušmanis. I'm head of Visual Design and Construction Department. And today I'm going to talk about a little bit about digital Rail Baltica. What does it mean? And what do we understand by this? And try to give you some sort of like a first steps or glimpse of what we are doing and how we are implementing building information management, but not just that. So that will be the presentation about. So a little bit about myself. So as mentioned, my name is Raitis. I'm here in RB Rail since January 2018 when I joined the company. Before that, I've been working in Trimble solutions and also in general been involved with BIM since 2012. So today in the agenda is about digitalization, then some topics, as I said, not just about building information management, but also about GIS and about asset register, and try to explain those things. Then I will a little bit explain how we organize the information delivery, some first acknowledgements, what we have so far, and then some brief summary. And as Liva mentioned, then about each and every after these these chapters, we will have questions, answers. We will see if you have any questions. We will try to provide the answers. So the first topic chapter is the digitalization and what we understand by that. So these three things, BIM, GIS, and AIM, and what are they? So building information management, geographic information system, and asset information management. And all of these things, they have something in common, and this in common thing is information. So actually, it's not about 3D models. It's not about some nice pictures or yeah, some representation of environment. It is also that, but it's more about the information what we collect, the information how we manage it, where we store it, how we utilize it. And this word information probably you will hear a lot throughout my presentation, because that is actually the main purpose of all of this what we are doing. It is the management of data, management of information, and making sure that the information we collect is reusable. We can use it in later stages, because construction, design and construction is very short time period compared to the life cycle of infrastructure. So we are probably talking about a couple of years in one stage, but then the infrastructure hopefully will work and serve for next 100 or even more years. So we have to take that into account when thinking that what we are delivering now, how we will utilize that information later in different stages. So where and how we started our process? So when I joined the company in 2018, there was some work done already, and that was started everything with BIM framework. And at that time, I can admit that we were focusing on BIM, and some other things came later. And BIM at the time was sort of like a buzzword that everyone used, and maybe not entirely everyone understood what it was. And I still believe that only some people do understand it, and we try to educate like how what does it mean and what do we need to achieve here. But we set the BIM framework, and it defined like the idea of how we approach our BIM journey, if I may call it that way. Then later came the next step was BIM strategy, and that was already detailed, or that is actually already a detailed set of rules, which includes BIM manual, it includes training material, it includes specific templates and some other things that the designers and later also construction companies can use, so that we would be able to collect this information in these certain standards, certain formats, so that it is reusable, and we are trying to make sure that this is consistent across the project. It doesn't matter in which country these deliverables are. It doesn't matter what kind of designer is doing it or what is the construction company, but the information should be delivered in the same approach, in the same way. And of course, by developing this BIM strategy at the time, we also sent a message to the market, basically saying that, okay, Rail Baltica is going to have this journey, and if you want to work together with us for this project, then you should be aware that these requirements are coming, and you shall be aware that you will be required to implement these things when you are working for our project. The next steps were software, and by software here I mean that also we are in the journey and the software is developing, but one thing that we needed is to what is understood by this common data environment, and I will explain a little bit more of that in the next slides. But basically we as an implementation company of a project, a coordinator of a project, we needed a place or let's say infrastructure of software where and how to manage all of this information which we receive. So that is the next step. We procured the software, went out with a public tender, and landed with a certain software solution. And of course, then I guess somewhere at that point also all the other things like asset management and GIS came into the picture, and we understood that actually we can't think of BIM as alone like a technology, because at the moment also there is like, I don't want to call it a trend, but there is a common approach that the GIS and BIM is sort of merging together, and this is what we are also now experimenting and trying to do. The same also go with asset management and asset register, that we have this information from different stages of the project, so we are trying to implement it and put it all together. The next, of course, then when we have the strategy and software in place, then we started the designs. Unfortunately, we were a little bit late with the software. That's why also some of our designs started in advance, and it was a little bit of a hassle how to catch up. And in some cases we still see some problems with that, but in majority of the cases, in the majority of the designs which are currently ongoing, we are utilizing these solutions, and then the strategy and the requirements toward the designer are there, and they have to follow those. And this is a work in progress in order to manage all of the information. And the next steps, of course, are construction, operations, and maintenance. And these are the next steps as I speak, because Rail Baltica at the moment, in general, I would say, there are different pieces of this puzzle, but in general, we are mainly in design phase. There are some construction activities starting, such as for Riga Central Station has recently kicked off with the construction stage. There are some individual objects in Estonia which are under construction, as well as in Lithuania, but the majority is still in design, and we are very soon about to start the construction tenders. And the construction stage is something that we are seriously now preparing for, because this will be the main working area for us for next couple of years. But then, of course, we have to think about operations and maintenance. And as I said, this information, this is the most important part. So we collect it during the design, but there are some certain things which we cannot collect during the design. As an example, just I can mention that if we install some kind of a asset or system or something, then we do not know the manufacturer. We do not know the exact specifications at this stage. So that will be defined during the construction stage. So we have to supplement that information later. So that is why also for the construction stage, it will be very, very important to collect this information, to put it. And what we are trying to achieve is that we gradually update this information, so that when we get to the operations and maintenance phase, then we already have collected this data and it's in place, it's stored, and it has its own classification. So this is the pre-work, and actually we are aiming for the operations and maintenance phase. So all what we are doing now, it's with the thought what we will do in the future. Just to make it like more public and to have more market interest in this and to raise awareness, all of our BIM documentation is publicly available. So you can go and download it. It's freely available in our website. The full manual, full standards, full templates, it's there. So anyone who is interested, they can go and share, because we also see that at least in the Baltics, in the infrastructure side, we are one of the first ones who are doing this kind of implementation. That's why we feel also some kind of a obligation to teach and also to hand out this information to other interest, those who have interest in this kind of a topic. Maybe those are public institutions, maybe those are students, maybe those are interested professionals who want to learn more about this topic. So that's why this information is publicly available, and anyone can go and download and read it. I mentioned the CDE, and usually CDE is something like a common data environment, which most people do understand and think that this is like a data repository. I would not call it that way. I just want to make sure, and what we see as a CDE is a cluster or let's say many different solutions which serve their own purpose at a certain time of a certain task within the project. So of course we have to store the data, and that is fine. So what is called here DMD, or data model and drawing management. So we have to manage that data. But then there is also some other systems like GIS, which I already mentioned, asset management. So, and all of these, they are solutions as such. So we need to think there is no one, let's say one piece of software or one piece of hardware that would support all of this. So it is put together by different pieces, and we have to make sure that this information travels from one solution to the other. At the moment, we are still in the phase that we are looking how to put these pieces together, because we don't want to have like a standalone solution. So that we have, but what we want them to work also together, and that is the next things and next job for I would say a couple of maybe not a couple of years, but for the next years to implement and make sure that these systems work together so that the information could freely travel from one system to the other, though filling the purpose of that system. And there's a question mark here because probably there is something at this stage that we haven't realized yet. And this is a learning process for us as well. We are not saying that we know, we have all the answers. No, there's a lot of unanswered questions there, and we are like trying to put it together piece by piece and trying to build this big picture. And this is a challenge, especially for this kind of a project, but this is the challenge that we have started, and there is no backing out at the moment. So as an example for this integration, like GIS and these models and then data repository, this is what we are looking at the moment, and trying to link together also the asset register part, because GIS, we see it's a very powerful tool for all kinds of activities, and also this is the place where we see that how we can build up the registers which we need, the databases that we need, and this would be sort of like a user interface between the database and the backend, and the user who sits at his computer uses just a web browser, for example, and nothing else is needed for them, and to get being able to pick to that point and to have that information which he needs in order to access that at any moment, any time, any place. You don't have to have like a proprietary software or something like that on your computer installed or anything. It's just like even from your phone you would be able to access that information, or tablet or something in the field. So this is the sort of the GIS we see as a gateway, but then there's a back end of many different things, and this is the challenge ahead of us, which we have now started a journey in order to implement that. If we talk more about the BIM specific, like building information management part, then we have in our project very different many stages of how the information gradually should be collected and unified. So we start from site investigations, when the first crews who start the design, they hit the ground there and they start to investigate what's there actually. So that includes geotechnical, topographical surveys, laser scanning, hydrology studies, etc., all what is required. Then comes the value engineering. In this stage, we conceptually design and choose the most economically advantageous option, so that we would understand from CapEx and from OpEx point of view which is the best option to go with the main design. Then we go into the master design, and this is at this stage we define the main design solutions with the target to start the construction tender process, so that we would have already like a mature enough design so that we would be able to predict as precise as possible what would be the capex costs, so that the construction companies would understand what they are required to do, how to calculate the quantities, and how to calculate the capex costs for this particular object or section or something. And then of course detailed technical design. This is when we arrive to the point where actually from geometrical point of view, this is more or less as far as it gets. So we have the detailed solution. Those are detailed geometry and attribute information. And this attribute information, I will show some examples later in the presentation, how we collect it, how we get there where we want to get in order to achieve also this operations and maintenance phase, and how to implement that. And of course, during the construction stage, as I said, we supplement that information. We put more information to those elements. We add more attributes. We add more information in that stage, so that when we get to the operations and maintenance, we have it in place. And at this stage, actually, we are quite in a unique situation with our project that we do not have infrastructure manager at the moment in the place, because we are building a new line through 3 countries, and there are still uncertainties how how this line will be operated and maintained. But what we are doing, we are putting the information in place so that whenever, whatever operator or facility manager or infrastructure manager comes into play, we would be able to hand them over this information. It would be classified in a sense that it would follow some classification, and they would be able to reuse that geometrical and, more importantly, non-geometrical information which comes together with each and every element and attribute. So this is sort of like our stages and introduction to this part, and just to understand that where we are. So we have 9 design sections for the main line, and I would say we are, depending on the schedule, depending on where we are in the project, this is sort of like the place where we are now. There are less advanced and more advanced stages. We are in the master design, and we have not reached yet the detailed technical design. That is what is upon us in the next stage, and maybe in a year or something I can report on the findings for those stages. So that was end of part 1. If we have any questions online, we can take them now. If not, we can proceed.
Don't have any questions yet. Let's proceed, and dear participants, don't hesitate and ask your questions right away in the chat section.
Yeah, during the presentation. So after the second part, we'll stop at similar slide, and we can take those questions there. Okay, then I continue. So I already mentioned these 3 whales, 3 topics: GIS, BIM, and asset register or asset information management. And there's a slight difference between asset register and asset information management, and I'll try to explain that. But just to explain a little bit more in detail, what do we do with these systems and how we plan to use it. So as I mentioned before, everything starts with site investigations, and the regular site investigations is one thing, and geotechnical is required, and topographical surveys are required, and so on, and nothing. We are not stepping away from the legislation which is in place, and every designer and everyone who works on the project, they have to follow the local legislation in every country, and that is mandatory, and that's it. But additionally, on top of that, we can have more precise requirements, more precise information that should be gathered during the site investigation stage. And here you see like a LIDAR scan of some section where we capture this information so that it is later can be used as a reference, as a starting point when and how to do the design works. And one example of this, this is just one example of LIDAR data capturing the existing situation. So here you can see the typical topographical survey plan with high voltage lines, and then compare that to the LIDAR data, and of course you can see immediately that the advantage which this kind of information gives us, that well, of course we have to take into account also the time when this was captured, depending on the temperatures and so on and so on, but we have a reference already, and it's easy even to maybe later to do some clash detections or something like that with this information if we have collected it. So this is also mandatory for the designers to do, on top of the requirements which they have to fulfill according to the legislation and so on. So of course this LIDAR data is okay, we collect it, and then what? As I said, this is like a starting point for capturing the existing situation, and in most cases we are a greenfield project, and we have the luxury of doing that. So of course the designers, they use the LIDAR data in order to create more precise existing situation, to model the existing situation, so that when those let's say excavations and cuts and embankments are done, then we can have more precise quantities, more precise volumes, thus also trying to achieve more precise results. And of course that those percentages, which might be maybe small, but if you count it for the whole railway line, for those 870 kilometers, then it sums up to significant amounts. So that is why we see the benefit and the value of creating and capturing this existing situation as precise as possible. Geotechnical information is another thing that we see the benefit of collecting that, because we not only for the design and construction process, but also for the historical purposes, we plan to store it, and it will be available there. So whenever there is a need or of doing something additional or anything, that we will have this historical information. And this is one of the places where there is interface between GIS and BIM. So we can have this information interpreted in many different ways. So we have the BIM model, we have the GIS information, the GIS platform, and we can let's say make the information in one platform to be transferred to the other platform and reuse it. And this is one of the advantages of using different systems and platforms, because each of them serve a different purpose, but maybe using a web browser or something like that, it's more easy to be accessible for the other persons. And we tend to store it. It's 2D, 3D information. It doesn't matter actually. So we can implement that information in embed that information in many different software solutions. As long as we have collected it the right way, as long as we have categorized it, then we can reuse it how and wherever we need and want. Again, just to elaborate a little bit on the 2D and 3D data. So here you can see a plan from GIS where 2D data is implemented with some design solutions on the plan view to order to better understand how does it where it is on the map, let's call it that way. But it also nowadays the GIS have the nice capability of actually representing also the 3D information and the BIM information. So what you see here, it's not a specially made model or anything like that for GIS. It's the same IFC format model which is imported into the GIS, and we can even side by side display GIS 3D or BIM model with a typical 2D information, and it's sort of like geo-reference together. So again, another use case, how to reuse this information, how to make the same information work for many different purposes, and this is what we try to achieve, and this is what we try to do. Another use case, how to reuse information, is visualizations. They are like, okay, pretty pictures, maybe made for general public and not so much for the engineers, but we reuse the same information. And I mean by we here, it is our designers' task to do it. And if we have the model and if it is precise, so we have the LIDAR, we have the design solution, we have even topography and everything. So from that we can proceed to the next, let's say, from this information that the visualization can be created. And you see that the noise wall location is there, the overpass is there, and of course there are elements added within the visualization just for the visualization purpose, but the basis is the model, and all of this information which we have collected throughout the stage of the design, that can be reused. Here's just another example, sort of this more or less the same shot from a visualization and from the BIM model. So we have the LIDAR on the back and serving as existing situation. We can easily understand let's say even the houses or any other objects which are in the field, and from that create this visualization using this BIM information as a basis, and from there we can proceed and create more environment realistic visualizations, because the visualization, it's important for the general public. They need to, if there's a person living in this house, they want to understand how this will affect their life and their work, and maybe the technical design solutions is not the best way how to communicate that. If he sees the presentation in the visualization material, then it's more clear for them how this will affect their daily life and work. Talking about the BIM models now a little bit more and the information which I told you. So according to our requirements, what we do, all the information which is stored and embedded within the model gradually grows. So here we have one example from value engineering. So it's a rough estimate, not rough estimate, but rough model. So it has some information. As you see here, it contains some basic information for which design section it is, what is the number or ID of the certain element or a certain, in this case it's a bridge, cut of a bridge. So what kind of, let's say, functional classification this element has, and so on and so on. So that information is included from the early stages of the project, so that later we can still reflect on that and follow what is happening and how it is happening. But as we advance through the different stages, and this is now a master design model, so you see that the graphical information grows and the non-graphical information grows. So we get more and more and more information about the same element, the same bridge. So we already have some material classifications. We have element classifications, so concrete classes, and so on and so on. All of this information is gradually being collected and implemented as we move through the process. And this is, of course, a task for our designers to do and follow that. We, as a client, we have to follow that this information is implemented. It is implemented according to our requirements, so that when we collect this information together from many different designers and from different companies, then it would, let's say, match, and we would be able to reuse the same information later in different stages of the project. So the information management, this is very crucial and very important step. And this is not about the 3D models. This is now managing the information. And the 3D, it just comes as a complementary aspect of data management, of information management. And of course, 3D is good for understanding the solution, for understanding the environment, for understanding the better to capture the essence of one or the other solution, because maybe in one time the certain cut or certain cross section does not represent every detail which needs to be seen. So those can be created at different places up on demand, and so on and so on. So this 3D comes with a benefit, but from asset management and from future perspective, we see more benefit in the information than in the actual 3D information, which comes together with that. Another example from another model, a bridge model, and I put this slide here just to tell you that we are not the ones who say that we will go without drawings. No, the drawings are there. The drawings are still in all of the 3 countries where we implement. They are still mandatory use case. They need to be there, and we are not ruling out them. We are not saying that we are going drawing less or something like that. No, but what we do ask, and what is our requirement, so that the drawings would be extracted from the model. So the model comes first, and then comes the drawing production. Now, again, this is something that we need to follow up, and we have to monitor if that is actually happening, or there are, it's not a secret, there are cases where this does not happen that way. It happens the vice versa. We try to catch those, we try to teach, we try to work together with the designers so that it would not happen. We want the model to be the basis, which contains all the information, and then if you need that information onto the drawing, you can extract that from the model. And this is our approach, how we are trying to approach this. There are a lot of challenges, and this looks nice and easy on the pictures and so on, but believe me, there's a hard work behind that, so that there's a discussions, there are explanations, there are many different negotiations behind all of this, so that we would be able to get to that level where we want to be. And I can tell you that we are not yet at the level where we want to be. One reason is that we still have a lot of design work ahead of us, and the other reason is that also this is a learning curve for everyone. and I will reflect that later into my presentation. This is just another example with the drawing and the model, and I think it's basic knowledge and basic understanding that the drawing shall come from the model. So the model comes first, you model everything, and then the drawing is created out of that. And if there are some changes in the design, then those are done firstly into the model, and then they are reflected automatically, less automatically, that depends from software to software, but they are reflected onto the drawing as well. So the main driver and the main information where it's stored, it should be the model and the database around that. To help a little bit, maybe our designers, what we did, we also developed these architectural landscaping and visual identity design guidelines. They are part of official design guidelines. So we have a book of rules how the designer should do the design, and what kind of standards they shall follow, and so on. And this is another example what we can give to the designer as a, as a base material, as a reference material. So we say, okay, so we have this, so this is how we want it to look like in the final design. So we have this sketch or this this preliminary design available for you to use. So please use it. Develop into the more detailed solutions, and we move on. Of course, we cannot do this for all design elements or all stations, like those big stations which are international stations. There the story is of course a little bit different, because all of them are unique, and the designer has to come with their proposals, designs, and so on and so on. But there are some elements which we can tell them how this design should, how we shall proceed. We have come to the end of part 2. I'm not sure if there are any questions at the moment. I don't. Yeah, just give me 1 second, very quickly. I need to check the questions myself at the moment. I will very quickly check. It seems that currently there are no questions for the second part, so I will also continue with the next chapter or next part. And the next part is about this information and delivery. So I talked about that we want to collect this information, and we want to collect and we need to collect in a unified way, and all the designers and all the involved companies have to follow the same rules and everything. But in this chapter, I would like to talk about a little bit how we do it, and maybe show also some examples. So when we talk about information collection, there are some rules and standards which we try to follow. The first, of course, is this which you see in the middle of this rectangular, or whatever is the shape called. In the middle, there is like a project delivery phase. So when we deliver the project, we need to collect this information, and we need to structure it. And how we do it, there are standards that help us. And so you see, for example, information management. There is ISO 19650, which has several chapters about how the information management and how we collect that information, how we structure it, and so on and so on. And then of course there is outer layers of asset project management, which again there is ISO 55000 and 21500, and then there is organizational management, which again is a different standard. So we start from the inner circle, and then we move out. And as I said, as we don't have infrastructure manager in place and not appointed, so we inside of the company, we are collecting this information. We are doing the information management, which is the blue line around the square, white square, and this is how we see our work at the moment. And then when we have this infrastructure manager, which will come and tell what are the procedures that they will use in order to use this information, then we will give them the information what we have, and then it's up to them to understand how to manage it. I know this is not an ordinary situation, because usually there should be infrastructure manager in place which comes and tells us, okay, this is our process, this is what we need it that way. Unfortunately, we are not in that position, so we have to work a little bit differently, and what we need to do, we need to come up with the solutions how to get there where we want to get. And this is the situation we work with. These are the circumstances we work with, and we shall continue to do our work. In order to collect the information, which I have mentioned before, and to structure that information, so I told in the beginning of presentation that we need some kind of a software solution to supplement that. And so we have a solution in place where we set up sort of like a locked environment between us, client, and the person or the legal entity or designer who is doing the design work in this case. So we create this link. We create this one project for us and for them, and they deliver the information to us using this system. The benefit of doing that is that all of this information, when it's delivered, how it's delivered, it has a paper, sort of like an audit trail, and we see how the information is delivered. Also the benefit is that when this information is delivered, both parties sees it. The difference is that we, on a client side, we collect this information, we store this information. The other party can access, they can see this information, but none of the parties can actually edit or modify that particular deliverable. And that is the sort of rule of thumb here, that whatever the information is delivered, whatever is delivered to the client in that deliverables package, it cannot be changed. It can be amended, new version can be submitted, a revision can be done, and so on and so on. But that particular package, so you can't do that, okay, I delivered this wrong file, so I will remove that file and place another file instead of that. No, it doesn't work that way. So whatever is delivered, it stays there. If you need, or designer needs to deliver something additional, okay, fine, you can do it, but that has a paper audit trail, and it has everyone who has done what in the system, that is visible. In case of any question or any doubt, we can go back and see what was delivered at that point, at that moment, and who did it and why did it. So both parties have access to this information. The transmissions mainly work only one way, so that the designer delivers something to the client. It could theoretically work the other way. At the moment, this is not the setup we use, because most of the communication is sort of deliverable communication is one way. Now, when we talk about, of course, some other exchange of information, not just deliverables, but there are some let's say other contract documentation. Of course, that travels both ways, but the deliverables mainly travel one way. And there is also work in progress location where the designer can just drop information which is not contractually binding. It's just for some information or something like that. The same works for the client. The client can share big data, and we needed this system because managing information is one thing, but managing huge amounts of information is another thing. So we are not talking about megabytes here. This is already like one deliverable package is gigabytes of information. And soon, I haven't checked the latest, but I believe we are well in terabytes already in a total amount of information, and we are still in the middle of design phase. So you can imagine how that information gradually will grow. So this is a huge amount of information which we need to cope with and we need to work with, and so this solution had to be able to support this kind of approach. So when this information comes and it is stored, it has audit trail, audit trail, and all of that is stored. It has a codification, and this codification for every deliverable is followed, so that we would be able to identify each and everything, and each or every of those code parts means something. so that we are able to identify the deliverables, we are able to categorize them, we are able to work and find them. So this is about the data management and how we manage the data which is coming from the designer, how we structure it, how we put it there. But the best thing, but still, and this is thing that we are currently starting to do, and this is, let's say, we are in a baby steps here. This is the other side of the solution, that we can actually use the information that we have received within the system, map it how we want and what we want to do, and we can actually visualize that information. So the same, it's not transferring information from one solution to the other solution. It's actually what we are now trying to do and investigating and seeing how it works, actually to reuse the same, let's say, file or the same model to do to capture the information, so that we don't have to copy paste it to some other place. So we work in one system. Now it's not all shiny and great. There are still some things that we need to improve and to work on. And I'm not saying that there is only one solution for this. And of course, we need to work on other. There has to be another solution. So because one. It's just there are so many things that needs to be done, and at the moment, as I said in the beginning, there is no one software solution that can do everything. So, but we try to explore and try to understand what is the best approach way forward. And as you can see here, all of the information which I showed previously in the screenshots, also about the model, about the classes and everything. So you have that available at your disposal. You can search for it, you can I don't know, color code it and so on, so you can manage that information, and there are use cases for that. There are different solutions which can be used for different reasons, but this is let's say this is one of the advantage. What I wanted to show with this is that we can reuse the same information, the same solution, and we don't have to jump between different solutions, different softwares, and so on and so on. So this is the main purpose of what I wanted to tell with this, and this is I see this is a benefit in that we do not copy paste to some different. So we have one single. I know it's cliche, but we have one single source of truth where this information is stored, and that is the target. I'm not saying we are fully there. There's still a long way to go, but that is what we want to build, and this is what we are planning to do. But in order to get that information, it's not straightforward. So we only see the end result, the nice shiny picture and the nice model at the end. But of course, there's a lot of work behind the scenes in order to get there. And this is from one of our designers who have described their workflow, how to get from the discipline model to this federated model where all comes together with this data-rich information. So there are different software solutions, different approaches, and according to our requirements, we are not requiring for the designer to use a specific software vendor or software tool or something like that. What we require is that at the end they deliver the information according to our requirements, and whatever tool they use and they see fit for that reason, fine. They can use it as long as they can deliver the end result. So that is the aim and that is the target. And of course, every designer, every engineer has their weapon of choice, how they see the best fit and how they can deliver this information. And there are many different software solutions out there. I think the market is getting bigger and bigger, and there are more and more different solutions that can be used. And if they can prove that they can deliver this information to us in a certain way, they are free to use this information. Again, another example of a workflow, how to get from let's say model to BIM model. So there are workflows. There is a work behind the scenes, because one solution is better for one thing, the other solution is better for the other thing. But at the end result is what we want to achieve, what we want to get there. And this is the sort of the end result, which I already showed in the previous model, previous screenshots, is that we have a model and we have a data rich model. So that is the reason, and all of these elements and everything. This information, again, repeating myself several times, that this is the information that we get so that we would have it in the database so that we can reuse it later. And this is one example here from, actually, this is a GIS solution where we are starting to build the database for asset register. So this is not information management, asset information management. This is asset register. So we register all the information what we have, we put it in one place, we put it all together in the database, so this database can be reused later. So it can be stored as in the previous by bigger, like primary assets or primarily level of information here, like a bridge, for example, or overpass. And then there's another level about each and every element, and so we can break it down to level that we need actually. And this is still work in progress, what you see here. So there are still some issues that we need to solve, and there are challenges that we face with this. But this is sort of the approach that we are taking at the moment, and we want to go forward, and we want to push it forward, and we want to get this to this result. And as the technology is also advancing, maybe 5 years or 10 years ago especially, it was not possible, would not have been possible to get this kind of information into using it across different platforms. But now it's still not 100% like shiny and polished, but the capabilities are starting to appear there, and this is what we are trying to take advantage, so that maybe in 2, 3, 5 more years it will be perfect, and this will be everyday life of any infrastructure manager or anything like that. So that's what we are trying to do. We are trying a little bit to push the boundaries here to explore these options and how to get there with what we want. So this was also next part. Do we have any questions?
Yeah, we have the first question, but okay. I will also take the opportunity and ask a question for myself. As I'm listening to you, you mentioned that in the construction phase there will be up to like 500 users in the BIM. And my question is as follows: so what kind of measures will there be in place to ensure the security of this information depository, and how to regulate the accesses?
Yeah, that is one of the challenges that we face, that as the project grows, also the access to this information needs to be granted to more and more people. And we have to think about this, and we are thinking about this, how to manage it. So one option is that the client holds all the keys to this, let's say, to accessing this information. But of course, all the people who access that, and all the companies and the private persons and legal entities who access this information, they have to go through some kind of a security background check, and they have to be trusted with this information, because information is good and sharing information is good, but as we are classified as a critical infrastructure, then of course this comes together also with the responsibility of this information not to share it to the people who don't need it. So the reality is that as soon as the information leaves our premises or our environment, we have no control over it, and that's the reality, because everyone outside of the bubble, as soon as the information leaves the bubble, we don't know what happens with it, and we have to limit this opportunity that we have to know who is accessing this information. And that is why setting strict rules for companies, setting strict rules for individuals, setting information flow workflows, that is the important part, and we have to try to manage it during the construction and design. In the design it's relatively easy, but during the construction process the supply chain grows significantly, and this is where we will face challenge to manage this information. But this is just strict policies. There is no other way, and implications if that information gets somewhere where it shouldn't be. So that's how we plan to address it.
Very well. And then the next question is here from Christy, asking, what are the possibilities for infrastructure manager to use all this data and software in the future?
I think the possibilities are very open, because as I said, we are creating a structure of data. We are creating a database, and database fields and database what we have. We have to make sure that this information is categorized. If that is categorized, and if that is in let's say in Excel terms, that if this cell and this column knows what it talks about, then it doesn't matter what system picks that information, and we can map that information to any particular software solution or system in the later stages, so that they can reuse this information. So at the moment, we don't see a big obstacle here. Of course, when we'll come to the practicalities of certain software or certain database and how to map them, that will be another solution, another thing that we will need to address. But we have to make sure that this information is categorized, and that is the priority number one, and this is what we are trying to do.
Just to specify on top of the same question, are we planning to include in the Rail Baltica BIM the main line of the railway, obviously, but are we planning also to include stations and infrastructure maintenance facilities? Is it going to be a comprehensive? Yes,
that is the plan. Yes, all the international stations are included. Also, the infrastructure facility. I forget the name now. Facilities, infrastructure facilities, they are there. Maintenance facilities, yes, they are there in this. Now, another topic is local stations, which is, I believe, still an open topic, because there every country has to do their homework. So that's a different story. But the international stations, freight terminals, and the infrastructure management facilities are of our scope. Yes.
Okay, right. On that, I think the questions have stopped now.
Okay.
Let's proceed.
Okay, so the part 3 is the acknowledgements, or what we can already tell, what we have seen and what we have learned from. And this will be, I would say, rather short chapter, and I just want to reflect on the things that we have done so far, and what we have seen so far, and there are some eight acknowledgements here. So these are the first 4. First is the setting clear requirements, and this is of course something that we see that it's also a problem if you do not set clear requirements. And this is not just for BIM or anything like that. This is for any design or any construction project. Does it include BIM or not? So if those requirements are not set, it must. Then later we have a lot of discussions, and we are not perfect, definitely not. And but we try to set those rules and try to set those requirements as early as possible and make them so that both parties understand. The client understands what is the expectation what he expects, and the designer understands what are client's expectations, and those needs to meet. And if there are some questions, they need to be raised as soon as possible, so that the later stages of the project we would not run into some issues. And I can tell you from experience that happens, and it's impossible, almost impossible, from the first time to define everything and to have everything set clear. But we learn from that experience, and we try to do the best as the design contracts go, as the construction contracts will start to go. We try to learn from previous experiences. The second is following the process, and usually maybe someone thinks that, okay, client says that they want, I will put it brutally, but client wants BIM, and that as far as it stops, and it doesn't work that way. The client has to understand what they require and why they do this. And the client must follow the progress, and they have to have the knowledge inside of the company, or at least they have to hire an external someone who knows what they are doing and how they are doing it, because you as a client, you need to understand what you will do with that information. Thus, you need to understand what is being delivered. Because if in the end of the project you will understand, okay, this information what has been delivered doesn't suit me, then what? So then it's too late. And that's why the client's involvement, I think, is very important. The client has to be educated. The client has to know what they are doing and why they are doing it. And they have to follow the progress, and they have to work together with the designer. They have to work together with the construction companies in order to follow the progress and to see how this is going. Is it the client itself? Is it like a additional consultancy for that? Is it an engineer or something like that? But there has to be the following the process. It's not enough that the client says I want BIM and then they will receive. They will receive something, but what did that be? No one will know. Everybody must learn. Third point here, that and this is a learning curve. This is not a normal procedure at the moment, at least not in the infrastructure, not in the business here, what we are doing and what we are implementing. Client must learn how to do these things and how to require what they need actually, and the consultant needs to learn, and this is a two-way street. One has to teach the other, and it's a compromise. It's a learning curve, and it's in many cases this is something new still in what we are almost at the end of 2020, but it's still something new for many people, and I believe this will be the same for next 5, 10, 20 years. The generations will change, and the workflows will change, and then maybe this will be a regular business as usual. But at the moment still we are there, that everybody must learn, and for many of the involved persons from both sides, this is the first time they encounter something like this. So there is a lot of learning curve there. But also the client must demand the results, because such as excuses like, okay, we usually don't do it this way, it's not, I would say this is not acceptable from the client's side. They have to push the designer to do the things that we're agreed to do, because always there is going to be some kind of discussions. There's going to be a lack of time, lack of budget, and something like that. And these things are inevitable, and they will happen. But we have to respect what has been agreed, and both parties have to respect that. And if that's not respected, then the client has to push and have to negotiate for better terms, because the contract has to be fulfilled, and both parties have to understand what they are doing. Having said that, I believe there is also a certain point of or certain degree of flexibility, because maybe sometimes, and I can speak from my experience, that clients are requesting something that they don't even understand what they are requesting. They are requesting some kind of, as one of my colleagues like to call it, Hollywood BIM, which is sort of like a nice pictures on the internet, and okay, we want that. Okay, but we have to understand what does it require, because every Hollywood BIM requires some kind of effort. There are people behind that who are doing it. There are hours, there is a schedule, there is cost in order to get there. So you can get there, and pretty much you can achieve those nice pictures and everything that the salespersons try to sell to you and claim what their software can do, and so on and so on. But you have to be reasonable. You have to understand what can be done and what cannot be done. And if you see that, okay, this is actually something that is useless and something that should not be done, then you have to be flexible. And this goes both sides. That the client has to be flexible, and the designer has to be flexible and understanding like how to do things. But we have to have some rules. And we have to communicate, and we have to have these daily or weekly or meetings and educate each other and to get to the end result. The big picture, client must keep it in mind, and this is something that goes together with the previous slide of what I said, that the client has to understand why they need it. They need to understand what they will do. There has to be the big picture. There has to be the strategy and the plan in place in order to get there. And you need to know what you need to do in order to get there. If you don't have that, then you will struggle, and everyone will struggle, and you will just ask for something that you don't understand why you ask it, because it's cool, because it's great, because I've seen it and I like it. so you have to have some kind of a background why you are doing this. And BIM is not alone, number 7. So as I said, like we started our journey with the BIM in mind. So we thought that, okay, we do the BIM strategy and we do everything BIM and so on. And it was nice. But the BIM is just one, I don't want to call it small part, but it's a part of something. But there are different technologies, different solutions out there, and the data management and information, that is what is important. The asset information management, the geographic information systems, the digitalization in general is the key. And the structure for the project, this is the key, not the BIM, not the GIS alone, not the asset management alone. Everything has to work together. And let's say requiring BIM doesn't mean much if you do not have the idea of what you're going to do with that data. And the last point I want to say that this is not easy. It's almost it's going to be 3 years here in this project, and since the beginning where we started and where we are now, there's a huge learning curve what we have gone through. I would say it has not been easy so far, and it will not be more easier in the next following years, and it requires a lot of effort. A lot of teaching, a lot of explaining, a lot of discussions, a lot of arguments, which technology, this or that, which file formats, which codification, and so on. So there are a lot of pros and cons to everything, and you have to evaluate and then get that information and review that information. So right people can help you, but most will not. Most will tell you that, okay, this is why do we do it? Why do we need it? And this is the part where you have to sell it. You have to explain, and what better to explain than actually to show. And if you have a tangible result that you can show and show to someone and tell that, okay, this is what we do, this is why we do it, this is how it will look like, then it's much more easy, and then people to start to see the benefit out of it. And there's usually these questions: is it worth it? Like, how much do you invest in order to do that? I don't have the numbers at the moment, but we have to keep the big picture in the mind, because as I said, design and construction will come and go, but the infrastructure will remain, and someone will have to maintain it for the next 100 years. And how much we will save during those 100 years based on the small investments what we are doing right now, I don't know. I think no one knows, and this cannot be measured in that criteria. So this is very hard to tell, but I'm convinced that what we do now will serve a greater good in the next phases. So right people in the right place are hard. They are very valuable. They are very hard to find. And on that note, I believe this is the most of the presentation. I'm almost at the end. There are still some summary slides, but if we have still some more questions.
Right, we don't have further questions now, so I think we can proceed then to the summary part.
Yeah, and the summary part is just to, I have ended my speech, and I will not bother you with BIM or AIM or GIS anymore. But just to remind that during these 4 sessions now we have covered in this Rail Baltica Academy so far, we have covered how the transport demand and benefits of a mega project were translated into the scope of Rail Baltica project. What is the Rail Baltica's approach on putting in place the world-class railway systems to guarantee safety, speed, and sustainability of the new line? Rail Baltica's approach to railway energy system deployment and enhance future passenger mobility and freight flow with nearly zero CO2 emissions and minimizing air pollution generated by the transportation sector. And the shortest one, Rail Baltica digital data strategy. So these 4 sessions, thank you for those who followed all of them. Thank you for those who followed today. And if you have any suggestions, to suggest any topics for the next sessions. As my colleague Liva mentioned, in the March, I believe, next year, we plan to have the next sessions. So if you have any specific topics in mind that we should cover, please submit them to academy@railbaltica.org. I believe, Liva, you mentioned also something about the page or form where to sign up for internship. Where that can be found, can you please remind again?
Indeed, we posted this internship application form in the chat, so people can access it and sign up. So please do so if you're interested in internships with us. I can also mention that the videos from these sections are available, from this academy, are available on our YouTube Rail Baltica profile. We're still planning to upload the electrification session, and Raitis, your session will be also up and running starting from the next week. If you have any further questions, write us. We have a designated email for contacting us. And having said that, we hope you remain satisfied with these sessions. And we will be approaching and inviting all of you to come back for another round of learning in March.
Yeah. Okay. Thank you. Thank you, everyone. Thank you for attending this session, and thank you a lot. That's all. Bye.
And happy Christmas. Goodbye.
True.